Hello dear students, in this video we will have a look at an alternative method to find the roots of a quadratic equation. The name of the method is completing the square method. Since we know that the standard or general form of a quadratic equation is ax squared plus bx plus c equals to 0, where the coefficient of x squared, that is a, cannot be 0. The degree 2 of a quadratic equation suggests a quadratic equation will have two roots. In order to find the roots of a quadratic equation using the method of completing the square, we need to remember the following three steps properly. In the first step, we need to shift the constant to the right hand side and get equation in the form ax squared plus bx equals to minus c. Step 2, we need to divide the terms throughout by the coefficient of x squared, that is a, to get equation in the form a by a x squared plus b by a x equals to minus c by a. On cancelling a by a, the coefficient of x squared, we will get equation in the form x squared plus, let's consider small letter b by small letter a as capital B, so bx, capital Bx equals to minus c by a. For the time being, let's consider as capital C. So we are considering capital B as small letter b by a and capital C as minus c by a. When we will have numeric values in the question, it won't be confusing. Now, in the final step, we will apply the identity x plus minus half into coefficient of x whole square equals to c plus half into coefficient of x square. The sign here, plus or minus, will depend on the sign that is given in the question. The steps here might be looking confusing, but once we apply these in the questions, there should not be any problem. So let's start. The first question is, we need to find the roots of the equation 2x squared minus 5x plus 3 equals to 0 by the method of completing the square. First and foremost, let's write the given equation, which is 2x squared minus 5x plus 3 equals to 0. Now, the first step, remember, it is to shift the constant from LHS to RHS. The constant here is plus 3. So, we need to shift it to the right hand side. On doing so, we will get equation in the form 2x squared minus 5x equals to minus 3. Here we have shifted the constant plus 3 to the right hand side and have got minus 3. Now the next step is to divide the terms throughout by the coefficient of x squared. Here the coefficient of x squared is 2. So dividing by 2 throughout, we will get 2 by 2 x squared minus 5 by 2 x equals to minus 3 by 2. We can cancel these 2's, 2 ones are 2, 2 ones are 2, and get the equation in the form x squared minus 5 by 2 x equals to minus 3 by 2. Now we will use the identity x plus minus half into coefficient of x whole square equals to constant c plus half into coefficient of x square. Here the coefficient of x is 5 by 2 and the sign is minus. So we will get x minus half into 5 by 2 whole square equals to minus 3 by 2 plus half into 5 by 2 square. 5 ones are 5, 2 twos are 4. So we will get x minus 5 by 4 whole square equals to minus 3 by 2 plus 5 by 4 whole square. 5 5s are 25, 4 4s are 16. Now on the right hand side we have denominators as 2 and 16. Taking the LCM, we will get the LCM as 16. 2 8s is 16, so on multiplying with minus 3, we will get minus 3 into 8s are minus 24. 16 1s is 16, so 1 into 25 will result into 25 itself. Now 25 minus 24 will give us 1, so we will get x minus 5 by 4 whole square equals to 1 by 16. On taking the square to the other side, we will get x minus 5 by 4 equals to under root 1 by 16. Now, under root 1 by 16 can be expressed as 1 1s are 1 and 16 as 4 4s are 16. So we can take 1 and 4 out of the square root. On doing so, we will get x minus 5 by 4 equals to plus minus 1 by 4. Remember, whenever we take any quantity out of the square root, it will either be plus or minus, so we'll have to write both the signs. Now we will consider the two cases as x minus 5 by 4 equals to 1 by 4 and x minus 5 by 4 equals to minus 1 by 4. Now taking minus 5 by 4 to the other side, we will have x equals to 1 by 4 plus 5 by 4 in the first case and x equals to minus 1 by 4 plus 5 by 4 in the second case. The common denominators in both the cases is 4, so we will have our LCM as 4. So x equals to 1 plus 5 by 4 and x equals to minus 1 plus 5 by 4. 5 plus 1 will be 6, so 6 by 4. Now cancelling with 2, we will get 2 3s are 6 and 2 2s are 4. On the other side, we will get x equals to 5 minus 1 as 4, so 4 by 4. 4 1s are 4, 4 1s are 4. So the two values of x are x equals to 3 by 2 and x equals to 1. So the two required roots of the quadratic equation are 3 by 2 and 1. The next question is, we need to find the roots of the equation 4x squared plus 3x plus 5 equals to 0 by the method of completing the square. The given equation is 4x squared plus 3x plus 5 equals to 0. In the first step, we will shift the constant to the right hand side. On doing so, we will get the equation in the form 4x squared plus 3x equals to minus 5. Taking plus 5 to the right hand side, we will get minus 5. Now, in the next step, we will divide all the terms by the coefficient of x squared. In this case, it is 4. So dividing by 4 throughout, we will get 4 by 4 x squared plus 3 by 4 x equals to minus 5 by 4. Here we can cancel 4 and 4. So we will get the equation in the form x squared plus 3 by 4x equals to minus 5 by 4. Now we will apply the identity x plus minus half into coefficient of x whole square equals to constant c plus half into coefficient of x square. Here the coefficient of x is 3 by 4 and the sign is positive plus. So we will have x plus half into 3 by 4 whole square equals to minus 5 by 4 plus half into 3 by 4 whole square. 3 ones are 3, 2 fours are 8. So we will have x plus 3 by 8 whole square equals to minus 5 by 4 plus 3 by 8 whole square. X plus 3 by 8 whole square equals to minus 5 by 4 plus 3 3s are 9, 8 8s are 64. The LCM of 4 and 64 will be 64 and 4 16s is 64. Multiplying 16 with minus 5, we will get minus 5 into 16 as minus 80 plus 64 ones are 64. On multiplying with 1, we will get 9 ones are 9. That is x plus 3 by 8 whole square equals to plus minus minus. Here the bigger number is 80, so the final sign will be minus. So 80 minus 9 will give us minus 71. X plus 3 by 8, taking the square to the other side, we will get square root of minus 71 by 64. Since square root of negative quantity belongs to set of complex number, that is, we will not get a real quantity, a real number. Hence, no real root exists for this given equation. Now on to the next question. We need to find the roots of the equation 5x square minus 6x minus 2 equals to 0 by the method of completing the square. Now here the given equation is 5x square minus 6x minus 2 equals to 0. In the first step, we will shift the constant to the right hand side. So we will get 5x square minus 6x equals to 2. Now in the next step, we'll have to divide all the terms by the coefficient of x square. Here the coefficient of x square is 5. So on dividing by 5 throughout, we will get 5 by 5 x square minus 6 by 5x equals to 2 by 5. We can cancel the 5's out here. Now we have got the equation as x square minus 6 by 5x equals to 2 by 5. In the next step, we will apply the identity, that is x plus minus half into coefficient of x whole square equals to constant c plus half into coefficient of x square. Here the coefficient of x is 6 by 5 and the sign is minus. So x minus half into 6 by 5, the coefficient of x whole square equals to constant 2 by 5 plus half into 6 by 5 square. We can cancel 6 with 2, which is in the denominator. 2 1s are 2, 2 3s are 6. Same thing here as well. 2 1s are 2, 2 3s are 6. After simplifying, we will get x minus 3 1s are 3 by 5. So x minus 3 by 5 whole square equals to 2 by 5 plus 3 by 5 square. 3 3s are 9, 5 5s are 25. Now taking LCM of 5 and 25, which will be 25. 5 5s are 25, so on multiplying with 5, 2 5s are 10. Plus 25 1s are 25, so on multiplying with 1, 9 1s are 9. X minus 3 by 5 whole square equals to 10 plus 9 will be 19, so 19 by 25. Now on taking the square to the other side, we will have x minus 3 by 5 equals to under root of 19 by 25. 19 is a prime number, so we cannot factorize it as product of primes. But 25 can be factorized as 5 into 5. 5 can be taken out of the square root. So we will have x minus 3 by 5 equals to plus minus under root 19 by 5. So we can split the equation to get the two roots as x minus 3 by 5 equals to root 19 by 5, and for the other root x minus 3 by 5 equals to minus root over 19 by 5. So we are taking plus root 19 and minus root 19 for the two roots. So now shifting minus 3 by 5 to the other side, we will get x equals to root 19 by 5 plus 3 by 5, and on the other side x equals to minus root 19 by 5 plus 3 by 5. The LCM will be 5, and on the numerator we will get root 19 plus 3. On the other side as well, the common denominator will be 5, and we will get minus root 19 plus 3 in the numerator. Further simplifying or simply shifting the terms, we will get x equals to 3 plus root 19 by 5 as our first root, and x equals to 3 minus root 19 by 5 as the other root. Now these are assignment questions which are similar to the ones which we have done in the video. So try to do these.